Okay. Today we have some of the winners here to present their project and ask them a few questions related to it. So if any of you guys in the meeting does have a question, feel free to throw them in the chat. The main agenda for today is that in a moment we'll be having Kuba present the presenters, and he will also be moderating the chat for questions and ask them if there's any questions. Each project has roughly around 10 minutes to present and Q&A. And the following projects will be presented in their respective order. First, we'll start out with Golem Slate by Doug. Secondly, More Covert with Doug. And third, Decentralized Machine Learning with Anshuman. Fourth, Golem Requester UI with Shry4net. And fifth and last one, Cargo Test with Ladislav. And after we finish presenting everything, then Connor from Gitcoin would like to have a word, and then I'll round off the stream afterwards. So without further ado, let's give it over to Kuba.
Awesome. Hi, everyone. My name is Kuba. I'm Chief Engineering at Golem. And first of all, let me thank you in the name of the whole team behind Golem. We're simply amazed around what you were able to achieve during this hackathon. And 1 year ago, we made this decision to optimize for developer experience and to make the Golem as easy and as smooth as possible to write applications in. And we're just so happy to see all of these apps being created, and it gives us a lot of sense of like why are we doing this, and like all the team is super thrilled. So thank you very much from the bottom of our hearts. And yeah, going through all these submissions was a blast. I can tell you like all of them. And on these events, as Philip mentioned, we share some of the coolest apps that were created on top of Golem. And we're going to have 4 people presenting 5 applications. So yeah, let's start with someone who probably actually needs no introduction. Doc, very, very active community member. If you've been to Discord, you saw Doc, and he's always super helpful, and he has been tinkering with the legacy Golem and new Golem, like probably since Alpha 1. Doc, you're welcome to tell us now about your project Slate, which is a code pen tool allowing devs to start coding on top of Golem as soon as possible.
Well, thank you very much for that warm introduction. I will try to live up to it. So let me see if I can share my screen, and let me know if you can see it first. So can you see my browser screen okay?
Yep.
Yes.
Great. So Golem Slate is designed to be a code pen, as Kuba mentioned. As he also mentioned that Golem has been redesigned to be very developer friendly, and I felt that this tool would help with that, because any application you want to write for, you can find JS fiddle, CSS fiddle, HTML fiddle, like every fiddle you can think of, it exists out there to play around with it on the web. And even though the documentation for Golem Alpha 2 and Alpha 3 is great, and you can get started in just a couple minutes, we were hoping that this would further make it easier to get started and just see kind of what it does. So when you come to the application, you can just click Create New Slate, which would take you into your Slate or code pen. The way it's designed is to run with each environment Dockerized in the back end, and this is for a couple reasons. One is for performance, to make sure that they can't impact each other too much, and 2 is for security, because when you can write code and execute things, you can mess things up pretty quickly, and you can spend a lot of time trying to secure that. So at the top, we can see that you can set your parameters for your script just like you can when you're writing a requester script. How much CPU, RAM, or disk do I need to run what I want to do? And what is my GVM image hash for what I'm trying to do? So this is actually exactly the Blender example that comes with the documentation. And it has the hash set up. It has the configuration set up on the top. On the left side, we can see our basic file list. This is actually looking at the files directly inside the Docker container. When you start up this application, just like when you're trying to run something in Golem, you need to make sure the Yagna daemon is running correctly in the background. So it actually shows you the Yagna log here that you can just click and see how's it going. It looks like it's running. It created the Yagna daemon. We've received our money from the faucet. Obviously in mainnet, this wouldn't be such a thing because you won't be getting free money from the faucet anymore. But at least for our test environment, it works well. So it's based on just creating a simple import file where all you have to do is say, how many tasks do I have? And this is the task getter, and it's just returning a number 0 to 6, or sorry, 0 to 60. And how many workers can I do? How much time do I have for this task? And how do I define what work I want to do? So this is almost an exact copy paste from the Blender example, where it's just defining that we want to take a blend file, generate some frames, and bring them back. So I can play around in here, and once I'm done, I can just click the run button. And then on the right, it's running the request to the Golem network. So it's using the Yagna daemon running in the background. And each Docker instance is running its own Yagna daemon, because at least in Alpha 3, there's still some stability issues, and we don't want a single Yagna daemon timing out or crashing, breaking all the pens. So it runs, and we can see the providers responding. I can see some results coming in, output 40, output 20. If I want, I can refresh the file list, but I'll wait till it's done. Two things that we added since the hackathon was these two buttons at the top. You can now stop it. So if you see that for some reason it's not running, or you made some mistake in your code and you know it's never going to finish, you can forcefully stop it. And if you decide, well, I want to restart from the beginning, I can reset my slate, which wipes it clean and gives you a new template. It restarts a new Yagna daemon, and you just start all over again. So when it's all done, it should give us a nice little table at the end, like the JS API does. And that is another thing, is that it is currently only using the TypeScript API, which is really the JS API. But the backend and all the Docker things underneath would work just as well with Python. So if I expand it out a little bit, I can see the nice table result telling me that it was successful, what my total cost was. I can refresh my file list here, and I can see that I have my output PNG files here on the left side. I can download them. And currently, it's not set up to show in the browser itself an image, but I can see that the file was downloaded. There's obviously lots of room for improvement to make it so maybe the PNG shows up here, and so on, user accounts, that type of thing. I think that mostly covers what Slate is, what it's intended to do. If I wanted to make changes, it would be as simple as changing the resolution that I'm telling it, or the number of samples that I want, save my script and run it again. So I can just sit here and play with it incrementally until I get my script working how I want it to.
Yeah, this project is so amazing. You know that the first time we saw it, it was like, oh, this has to be part of our developer onboarding flow. We have to have this some way in the documentation, and you know, like Golem Slate obviously is inspired by CodePen. And do you think that this project could become, you know, as big as that with further adoption of Golem network and be some kind of a playground for developers in the future?
I definitely think it could be a playground. And one thing I failed to mention is that it does something that the current environment doesn't, which is your requester needs to stay online while the work is being done, right? Slate runs in the background for you. So you can close this tab and come back to it in 10 minutes, 15 minutes, and your results are there, which is one of the pain points currently in development. So I absolutely think it could grow, where you maybe have an account, you have an allocated amount of space, which is exactly why we did it as a Docker container, so that the user's space is limited. It can be expanded to be able to install extra modules, whether in Node or Python. I think it would be a great way to potentially become something you can just paste in a script that someone has said, hey, try this out. And of course, there's also dreams of it potentially hooking into some sort of marketplace where someone has an app developed and you say, oh, great, let me try that and just run it on my Slate with my wallet connected, and it will use the GLM out of my wallet to run this thing.
Yes, that would be amazing. Like, do you have any plans to maintain the project and like perhaps launch a public site for it? And
so it is currently hosted as part of the Decompute network, which is a project I was working on some. Mm-hmm. So if you go to slate.decompute, that is their initiative, is to be able to make it easier to onboard developers for different, not just Golem, but for other decentralized networking solutions. So whether that's Filecoin or Saya or Golem, honestly, I think you guys have the market cornered when it comes to decentralized computing. There's lots of ideas, but there's only one thing that you can actually run today, and that's Golem. So yes, as mainnet comes, where we can actually start to look at how do we move funds around, how do we pay for things, how do we monetize things, I definitely think it becomes something that could be maintained.
Yeah, and mainnet is coming. Okay, Derek. So let's go into your second project, No More Covert, which is a way to design space using Golem.
Yes. Yes. So this is, I was racking my brain trying to think of different categories that I could enter into, and I came up with a bunch of ideas. But this one I felt, especially with the current environment and working environment, may actually be applicable. So what it does is it lets you lay out a room with a very beautiful UI. You may notice that it's different between Slate and Covert, but that's intentional. Slate got most of the love as far as front end and back end work, and this was a little bit less, but I think it's pretty in its own way. So you can lay out a room, and right now we fixed the size to about 16 by 12, but that's not a limitation in the back end. So the back end script could work with any room size, any number of objects. The only limitation you have is your computation power, which that's where the Golem network comes in. You can throw it more nodes, bigger nodes, and just run with it. But sometimes scripts are a little bit hard to understand exactly what they're doing. So that's why we wanted to at least make a basic UI. So the concept is you have movable objects, which are these yellow things, and you can create a fixed object, which are these purple things, and you can say the number of people you want in the space, and you can add a fixed person. So if we picture perhaps a restaurant layout where you come in and there's a big counter there, and there's some people standing behind it, taking orders, and there's some tables in the area that people would sit at, and maybe their layout is currently like this. The scale of this is that each one of these boxes is about 1 foot. So 3 would be 1 meter, and then 6 would be 2 meters. And if we see that right now, if I have a person sitting at each of these tables, they're too close. They don't meet these 2 meter criteria, right? So I'm going to say, this is my layout. These are the only 2 people that need to stay where they are. So these 2 people need to stay here because they're working behind the counter. But I still want to fit 4 people in, and you can move the tables anywhere you want to, right? So when I say calculate, you'll see the page gets updated as it's sending the request to the Golem network. So unlike Slate, we don't see the beautiful log scrolling by because I think the user of this doesn't really care that it's sending requests to the Golem network. But we can see that it's processing, and it will return us a result. Now you may notice it likes to throw furniture to the side of the room, which is not so practical for a restaurant, but at least it meets the first criteria of making sure everyone is 6 feet apart. So we can see that it shoved one person gets all 4 tables, so he's very greedy with tables, and everyone else has to stand and eat their food. So maybe not somewhere you want to go today, but at least you're safe from COVID. But the backend that does this work is based on Google's OR tools, which is a constraint programming tool. And it wouldn't be too difficult to improve it to say, okay, the people need to stay 6 feet apart and they need to be near a table. Or maybe these 4 people should be near a table, these 2 people don't need to be near a table. And if you have, for example, a different shape of a room that's not always a perfect rectangle, you could also fit that in as a fixed object, saying, well, this corner actually can't fit anyone. It's a closet, it's something else like this. So it takes these parameters and puts them into a problem that the constraint programming solver
Did the audio go? Can anyone hear me?
No, I can hear you. We
Now
can't
I can hear you, but
Yeah.
I didn't hear talk.
Oh, okay.
Yeah, me neither.
Oh.
Yeah, I can hear. I think Derek accidentally muted.
This stream is also.
He's having connection issues.
Can you hear me?
Oh, we hear you now.
Yeah.
I think someone muted me because it, yeah, anyway. Or maybe, yeah, I don't know, but I didn't mute it. So where did I get cut off?
I don't remember now.
All the way back at the beginning? This is COVID.
No. You are telling about throwing the furniture to the side.
Oh, okay. Well, so what I was saying is that it throws the furniture to the side, which is not a restaurant you would want to be at. But that can definitely be improved because right now the main constraint that the program has is that the people must be 6 feet apart. It wouldn't be too difficult to add additional constraints saying these people need to be within this distance of a working space, for example, in an office. And the size can also be increased. I've run it on things as big as 20 by 30 with 15 people, and it's fine, just depending on the size of the node you send it to. And what I was showing here with this rectangle is that if you have a room that is not perfectly rectangular, you can just block out portions of it with a fixed furniture object. So this could also block out a strange corner, or maybe the supply closet where you don't expect people to be working or sitting. So that's pretty much COVID.
Kuba, you're muted.
Now, yeah,
Yes,
possibly
I
you
can
can hear me now. So I got to ask this question. Like at which number, like what number of people or tables or room should be here so it breaks down locally and you have to go through Golem?
That's a good question. When I was testing with a small room size, let me back up a little bit actually. With a constraint programming solver, there's 2 ways to do it. One is to say, just give me any solution that will work. The next is to say, give me the best solution that will work. Okay, so really what you would want is this is showing you the any solution, which is saying any way that you can fit everything in the room with people 6 feet apart. That's easy. You can do probably as many people as would possibly fit in the space. You could do locally up to maybe, I don't know, 20 or 30 people, right? But once you want to touch on give me the best solution, you can throw limitless computing power at that. And that would be optimizing, make sure you fit as many people in the room and keep them as far apart as possible. 6 feet being the minimum, but if you can do 7 feet, great, or 8 feet, or maximize how many people can sit at a desk and be 6 feet apart. So once you get into the maximizing it, I started immediately breaking the slower nodes on the Golem network. So because right now, picking some of the nodes, you can't really determine exactly how strong they are. So even if they say they have 4 computing cores and 8 gigabytes of RAM, they may not be the fastest 4 cores. So it does scale based on the number of cores you give it. So the OR tools backend can scale that way. And you can also break the room apart into smaller pieces if you wanted to have multiple nodes running the issue. So for example, in Office, you could have it say, maximize each of these 5 rooms and then give me the best solution that compiles them all together. That type of compiling is not in CoFID right now. So to answer your question, it gets really easy to break a local computer if you want to maximize. And I initially wrote it that way and turned it off because it's quite disappointing when you keep seeing it spinning. So I wanted to make sure that you could see some results. And then, of course, it can be changed back to using the maximize option.
Yes, thank you. These 2 projects are absolutely amazing, but yeah, we have to go further since the time is ticking. Anshuman 73, do I pronounce it correctly? These nicks are so crazy. Could you please present your decentralized machine learning on Golem?
Sure. And yeah, you got the name almost right. Let me just get set up with sharing my screen. Is my screen visible?
Yep, we see it.
I'm audible. Oh, awesome. Okay. So it's really hard to follow up Doc, and I think my project isn't as visual and appealing as Doc's is. But let me just explain what the idea is behind decentralized machine learning. So I'm actually a student researcher, and what happens is that when you try to build machine learning models, you are often restricted by the computing power that you have. Especially, it happened to me a lot after COVID. I couldn't access our university servers while sitting at home, which meant that I was restricted to the computing power I had locally on my laptop. And I wanted to sort of fix that because when I tried to actually, the motivation to build this project was that when I actually tried to run something on AWS, I ended up leaving it up online, and I racked up like a really huge bill, which is enough to buy groceries for a month, to be very honest. So that was really embarrassing time. So I decided to take what is known as federated learning. What you're effectively doing is that you have one controller node, which builds a machine learning model and sends it off to various devices. This was originally built to do on phones and stuff like that, where phones have a lot of idle power when they're charging. And the idea is that you initiate a model on one central server, and then you make the training data available to the devices, and you make the model available to the devices. The model update their own locally trained models and send it back to the server, which in our case will be the requester node. And then the requester node just combines those central points. Like you can see these small data points being sent back, and then it just builds a central model to improve on. Now, it's not nearly as, again, very aesthetically pleasing. So let me just go ahead and start the code, and then I'll try and explain, because it takes a lot of time. You cannot get an immediate output. So here's the first step. The model is initiated locally, and you can see that this is not exactly a great model. These are randomized weights in a machine learning model, and then that simply yields about 12% accuracy. This is the MNSIT model, which means that even if you pick at random, you can probably get 10% accuracy without breaking a sweat. As you can see, the training then starts. We begin training the round 1. This saving model weights for round 0 is where the model is initialized and the weights are saved. In round 1, these weights are broadcasted to all the nodes that participate. I have set a limit of 4 nodes for the meantime, and also to note that I'm using it on my own subnet. You can perfectly run it fine on community subnet, but it is slightly slower because I think there's a lot of nodes that exited after the hackathon. So there are not a lot of powerful nodes. I just set up 4 DigitalOcean VPS, and I'm running just on that for the demo. This may take a while. I've seen it takes about 3 minutes for each round to be completed. And I want you to note that its accuracy is about 12%. And as soon as we get the first round that's completed, we'll see an immediate jump in the accuracy. Another thing to note that for the POC, we are using a very small model. I mean, to anybody who's done machine learning in the past, you'll notice that this is not a very strong model. The idea behind it is just to provide a POC. And we should soon see the results. In the meantime, let me just go ahead and explain more about how it works. So TensorFlow Federated was another model that was built for this process, but Google only does it for simulation purposes. You cannot currently use this library and actually run it across on your own set of servers or own set of devices. But you can pretty much do a lot of testing on your local device to see whether your model will converge in a federated environment or not. I encourage you to check this out. I do have some code known as server.py, which will allow anybody who's looking to see if the model will converge. This will provide you a base for testing if the model will converge on a federated environment. Another thing to note, how easy it is to change models or build a model is I provided something known as model-base.py. You can simply, if you want to iterate on your models, you can simply add your model layers, your machine learning model layers. I was trying out with another machine learning model, but it'll take a lot more time for the demo. And you can compile it regarding whatever optimizers or losses that you might want. And then these are just some helper functions. But this module will actually provide the basis of where you can specify the model, and then you can simply just get started. Currently, the Docker does contain the data set, but as the internet connectivity is allowed on Golem, you should probably be able to put that in your client where you can download it from a central repository and then simply just, you can one Docker with TensorFlow or whatever libraries that you're using will be more than enough to run any sort of machine learning model that you want. And as you can see here, slowly our providers are sending back the trained models, their locally trained models, which we will then converge as soon as I think the first node sends back the data. All right, perfect. Yeah, so we can see that it took about 225, I think that's about 4 minutes of time. And yeah, we see an immediate jump in the accuracy. Once the round 2 was finished, again, we're doing the same thing. We converged these models locally, we combined these models locally, and then we broadcasted those models back to our providers to do the second round of them. This basically means that the model has achieved one singular state and is ready for a second round. You can try out these codes available on this URL. I think they have been made public on the blog post that Golem published. So feel free to check it out. That's practically it for the demo. I can wait another 3-4 minutes for the second round to converge, but I'd be open to questions in the meantime.
Yeah, ladies and gentlemen, this is how the Skynet was born, basically. But seriously, the machine learning and, by the way, TensorFlow, these things were always on our radar. We believe, this is one of the use cases for new Golem, and it's a blast to see someone working on that. Anshuman, I wanted to ask you a question about the sentence that you wrote in your GitHub README. You wrote that as we move to the mainnet, you can expect to train increasingly difficult and useful models on Golem. So what is the vision here? Like, what do you envision the roadmap could be here?
Right. So I think I would say the roadmap is only going to be there because of the use case I built it for. I built it for personal researchers because obviously if you're working in a facility which has access to high-level resources, you would probably be working on something that you wouldn't want to broadcast to a lot of people. So you have the resources to do that on your central or on-premises devices. The idea is that once we move to mainnet and some of the problems such as 30-minute limit or the internet connectivity are solved, and especially I'm waiting for GPU support, to be very honest. Once these 3-4 things are actually set down, I would actually pretty much have access to unlimited GPU power in some ways. So I was looking at Clay Golem's statistics page. I think it said we have somewhere around 1 TB of memory, which is RAM, and then we have somewhere around 100 cores or 200 cores. And that's practically labeling what supercomputer is, right? So a supercomputer today is used for research purposes. It's used for purposes, especially a lot more in academia as it is used in real life. So I can actually expect people, or I would envision people using Golem as their own personal at-home supercomputer access, which is something you can't get if you're not involved in academia.
And where this kind of the data, the models, where they could be? Do you consider other decentralized platforms and protocols be involved in that?
So I guess I think one thing that I'm again excited about is subnetting on Golem. I think I'm not sure if I understood your question correctly, but soon as we go ahead, I would expect that specific enthusiasts would come together to build their own subnets. That means people who are interested in machine learning will probably end up sharing their own resources as well. For example, if I have a high performance computing at home, I would probably be able to share it with other people working on machine learning problems, and I would actually be earning money for it. So anybody who is involved in the same set of things as other people, humans have a tendency to form communities. And I expect that these smaller communities will definitely come on Golem as we go forward. I hope I answered the question correctly.
Yeah, like that. Actually, that's a very interesting take that I wasn't asking about, but I'll take it with me. And thinking about subnets as communities is very, very interesting. Yeah, thank you so much for this project, and let's move on with the fourth one, right? But before we go, I can see on YouTube chat that someone is saying that they want Snarks Prover as a use case. So just to mention it, one of our developers is working on an experiment around this. It's very I'm very hopeful that this will be possible on a production level. But for now, we have some positive experiments results, and this kind of prover on Golem is already working. Okay, so let's go to the fourth one. Man, that's a really hard nick to pronounce. 3-4-net Golem requester UI.
Hello, I'm audible.
Hi. Yes,
Hi.
you are.
Yep. Thank you. Greetings, everyone. Let me share my screen. Yep.
Looks good. We see it.
Yep. Thank you. Greetings, everyone. Please allow me to introduce myself. I am Sridhar. I'm from India. I and my team member are relatively new to blockchain, and I think this is loading. Can you see my screen?
It's just loading fast too.
Oh, okay. Just give me a second. Yep. Can you see my screen again?
Yep.
Thank you. Okay, yeah, there it is. Yep. Again, we try to put together some UI and some backend changes. We're just calling it as a Golem requester UI, user-friendly design. As part of this presentation, we have a lot of slides just to convey our idea. We have a very short demo, partially working POC, you can say, and there can be some questions after that. Just a note that some of our ideas can overlap or contradict because of the following reasons. Next. As our first enhancement, we have put together the various console commands that are needed by Yagna as requester into a UI. We have grouped together somewhat like that. The Yagna can be installed over a click of a button. The service can be started over a click of a button. The payment initialization. So all the Yagna commands, we actually put it as part of the UI, which would actually make a developer's life easy. This is partially working as of now. We have tested most of the scripts, but we have not integrated that with the complete user workflow. Next. While we were exploring the Golem's ecosystem, we kind of found some similarity with the automobile sector, and we try to make an analogy of that. So, for example, in the automobile sector, vehicle is a main entity. The manufacturer is a who designs the vehicles, consumer uses the vehicle, gas station powers the vehicle, and the road highways provide infrastructure and connectivity. Similar to that, the Golem actually has an app as a main entity. The current requester designs the app. The requester also uses the app. The provider powers up the app, provides the CPU, etc. And the Golem network provides the infrastructure and the connectivity. So what we saw is that the existing requester kind of performs the role of a creator and the requester both. So we thought of separating that as two different roles, a creator who will design the app and the requester who is going to use the app. The one reason or one important distinction is that the creator can be given credit for designing the app. Since these two are right now tied up together, it's something like the requester even has to pay for the same thing. That's how the currently it is there as per our understanding. So this is actually the second enhancement that we proposed. We have defined the workflow for this in the UI, but we could not make that workflow complete yet. So, for example, the requester is in an entirely separate tab, and the creator is a separate tab, and each of them has different set of components that are required to run in itself. Next, from a very high level perspective, the Golem's ecosystem, right, can be, with respect to a requester, can be grouped somewhat as follows. There are some certain input artifacts. There is an input processing subsystem, we can say, which runs Node.js, Python, etc. There are some apps. There is a backend Yagna engine. Then there is a output processing subsystem. Docker runs, etc. And once they are processed and they are sent back as an output artifacts to the back to the requester. Currently, this line is actually the boundary of the requester, and what we try to do is that we try to move this line over there to the left, and we see if we can make this input processing subsystem also as part of the provider. So when we do that, there is a lot of scope in the app's reusability, in such that the users who are also not the app designers can actually can also use the apps, not just app designers. Even the apps can be used by anyone, and these parts can actually be even hosted as a separate UI. and people can go to that app gallery and then use it for their own. So this is the third enhancement we try to do. Again, moving that input processing subsystem as a provider responsibility. And how we depicted is that it can have a set of apps, and as more people develop their applications, this will grow. You can also have your own local set of apps that you want to specifically run for yourself or as a private apps, and globally people can use it on their own. And anything that is selected over here, I think it will be, for example, for the Blender, this is the part they can input the project folders, where the output are going to be, and what is the input Blender. This is just an example we took from Blender. And we can just say start the instance, and the new request instance is going to come up. And if they say create new, then it will be treated, this whole thing will be treated as a creator rather than as a requester. So this is the third enhancement we proposed. Again, we could not we define the models, we define how it can be done, we define the sequencer that can be used for doing it, but we could not complete the functionality of the UI. I'll just show a short demo of the existing UI. So this is how the current UI looks like. It's very basic setup. We had, which shows what is the version of Yagna that is currently installed. It shows the app is running. If it is running, what is the app key? So on if it can, you can use. Currently, it is not implemented yet. These scripts are not integrated to this UI yet. So just with a single click, the developers can actually set it up faster. Here is the app gallery, the same what we saw in that in the slides. Now people can click on the Blender or any other gallery apps, and the respective parameters would be shown up over here. And on starting up an instance, a new requester instance will come up, and it will, from here, when you run the requester, this is going to run in the background, and it is going to come up with the output of it. Similar to that, a creator will have its own set of, it is not yet, these are not yet completed. We just went through these two. So mostly this is what has been done as part of this hackathon. So any questions?
Yeah, thank you, Shri. I absolutely love how you pursue this onboarding experience for developer, because this is what this project is about. And I know it may be not looking like very polished, but the actual core features here are like super interesting. I wonder if you would hypothetically take this project further, how do you envision the next steps and the roadmap for it? What would you be doing?
I guess what can be done is that there are more app designers. I think one of the first thing is to separate out those roles of the designer and the developer, and that can actually have more app designers coming in, and we can do that by defining some set of standards of how the input can be. There can be a set of input parameters for that. Like it can be a stream of strings, or it can be a stream of files. Those can be defined in the same way. The output also can be defined and can be standardized. And once that is set up, there will be more apps that would be coming up into the app gallery. And even with the existing infrastructure, the part of it where the Node.js and the Python are running, right? They can actually be moved over to as a Docker setup, and it can be run as a provider rather than as a as part of the requester itself. So that can make things easier for people who just want to request. For example, let's say I want a text effect to be done. I don't want anything else, so I can just simply put a text as the input and just say, give me the output, and it in the back it is going to run and it is going to just give me the output. So there can be more requesters that will be coming into our and the reusability of the different app designers.
Yeah, this is actually, this part is a perfect insight. Like, we actually believe this is how the how personas for Golem are structured. There are creators, people that are creating applications, that are requesters, that are actually people that need some computational power, and then there are providers. So free entities, like, we've been simplifying it a lot since it was alpha, and we're really focusing on developers. But yeah, this is like a very, very, very good insight. And I guess, like, if we could have this and App Gallery and integrated with Slate, that would be a power horse. Like, that would be so awesome.
Yes, I agree.
Anyway, thanks so much again, and let's go to our last project.
Thanks, everyone.
Thanks. By Sladacek, Slate sick. I don't know.
Hi, I'm Vladislav Sladacek.
Yeah, Sladacek, sure.
I'm from Czech Republic, and I will try to share my screen. Can you see my screen?
Not yet.
Now?
Yep, now it's up.
So, my name is Vladislav Sladacek. I'm from Czech Republic, and I will today talk about my project named Golem Cargo Test. The theme is software testing. All software projects contain certain amount of tests. Sometimes in certain areas, these tests are really slow. For example, when we do some computations, cryptography, image processing, and so on, a test can take even several hours to finish. This can be a real problem because tests are most useful when we don't have time to run them in situations where, for example, there is a bug which must be fixed in production, or there are last-minute changes. We are able to do very stupid mistakes in which such as can be caught by such tests, but we don't have time to run it. What to do? How can Golem network help in our situation? The idea is simple. We can split our tests into small groups and run each group in parallel on separate Golem node. Because the distribution of duration of the tests is different. There are slow tests and fast tests. We need to optimize the distribution. So we need to combine tests in each batch so that all the batches are of approximately the same duration. We can use the advantage of Golem network so that we can execute any number of nodes, and we can start from a given planned total time and execute enough Golem nodes to achieve that goal. So, for example, when the developer wants to have the test finished in 5 minutes, he can start from that goal and let the executor execute enough nodes to achieve that. For planning the groups of tests, we can use adaptive approach. So in first run, we collect timing information, duration of each particular test, and in next run we can use this information for making optimal batches. Concrete implementation, I tried the idea with Rust tooling, with Rust programming language and Rust environment. This choice is because these tools are well designed and very consistent, but with a little effort, the script can be ported for any other test framework, for example, C++, GTest, Python, Java, whatever. I used virtual Golem network for my tests. For people who do not know Rust tooling, Rust has only one CLI command line tool, which is named Cargo, and this tool does everything: compiling software, testing, benchmarking, linting, and so on. And when you want to run all the tests of your project, you just type cargo tests and enter, and it's all finished. I created a replacement for this command, which is named Golem cargo test. And this replacement does following. First, it calls the original cargo to build projects and list tests. Then it computes optimal distribution of tests into batches, sends test binaries to Golem nodes, executes the scripts so that tests get executed, and finally it collects results. And then from the results, a summary is printed and a log is created. I prepared for you 3 simple screenshots of which should show how it works. First screenshot shows launching the framework. We can see that the script was executed with 2 parameters. First parameter defines the goal time, 200 seconds, and the subnet. The framework created 3 batches. First of them contains 217 seconds of tests. The second one, 202 seconds, and so on. Then the nodes get launched and tests start. In the second screenshot, we can see the finished computation. There is a test summary and the name of the log. And the final one shows what is contained in the log. The log is organized by groups. There is the original output of the test. If there were errors, we could see errors here, and timing information to be used in next run. And that's all.
Yeah, Ladisław, thank you. First, the use case is spot on. Like, we had this in our analysis for a very long time, that continuous integration is a use case for New Golem. And the idea around parameterization, I mean, like the targeting, the build time is amazing. I had this problem with build times that are too long for, like, in pretty much almost every team that I've been working in. So yeah, that's a really, really great idea. I wonder, let me just look into the chats. I lost it. Sorry, I lost the window here. Yeah, you've mentioned that once we get past some limitations of Golem.
The time is the biggest limitation. Can you hear me?
Yes, we can hear you.
So I don't think the time is the greatest problem, but the limitation in inability to execute network commands is important. Also, the fact that you don't have GPUs and so on. and there will always be limitations in tests because of test data. Because when you have a project which has a terabyte of input files, it's not a good idea to send that terabyte to all that nodes. So so I think now the main limitation is with the network. It's I think also the main reason why you can't create a full CI framework, because for example, when you want to compile, you need that nodes to communicate with one with another, because otherwise it's different to compile one file. It lasts a second, and run a 1 minute test. In the case of test, you don't need communication, but when compiling, you need it.
And do you often run cargo tests that are like taking like a big amount of time, and this is why you created
Sometimes.
this? Or? Okay.
No. For me, it was mainly a learning experiments. Learning experience. I wanted to try something new and learn about new technology. It is not from a real need, but I think it's a future of computation, such a network as yours, because people will have simple computers, and when will compilation needed, they will just send it to a cloud or to similar network.
Yeah, like very cool project, like for a learning experience. Like thank you very much, Ladislav. And yeah, I guess that's it for the projects. I wanted to thank all the presenters and all the hackers that submitted projects. They were all so amazing, and I'd like to pass the voice to Connor from Gitcoin. Also, big kudos to Gitcoin for providing such a cool platform for us to be able to host this hackathon. It was an amazing experience. Thank you.
Awesome. I love to hear that. Yeah, no, I was going to say the same thing to you guys. Just thank you so much for running this event. I think you guys put on a really fun one, and I'm sure the community appreciates it as well. And thanks to everyone who participated as well. I think that, we had a good mix of, people that were kind of already in the Golem community, and then maybe people who, were Ethereum or blockchain devs, but hadn't really played around with Golem. And then we even had some like brand new developers to blockchain, it seems like, with Requester specifically on this call. So I love to see that variety and kind of how we can bring the community together there. But yeah, and what really surprised me, I think, especially from the projects we saw here, are like the amount of really just infrastructure focused projects and like developer tools. And this is all stuff that now, other people can build on top of in the future. And that can continue being used. So it's kind of setting the groundwork, like like Slate and Demo and Requester and Cargo Test. Like almost all of these are reusable and are going to be really valuable to the community. And from what I saw on GitHub as well, they all just had like very good documentation. The steps to get set up were all there, and so it's really just props to you guys, the developers, for building this groundwork for everybody to use. And then the app layer also was pretty great. I think CoFUD was a really interesting project because one, it has an actual kind of use case that's very relevant to the world today, and it's kind of an interesting way to use the Golem processing power network. So it's definitely relevant to the real world. And there are of course other winners that we didn't get to see today, but some other interesting ones on the app layers that I liked were Sumer, I think it was called. It was kind of like a DeFi and a gaming combination, where you can earn, and that seemed really cool. And then there's a chess game as well, and I would love to play chess on Golem. So I know we didn't get to see those, but maybe if you guys check out the blog post that Golem put up, you can check out those repos and see the other cool things that were built. So yeah, I just want to say thank you guys again for doing this with us. Golem, you guys are awesome, and the community as well, I think, really stepped up, and it's amazing to see the projects that were built in such a short time.
Thank you so much. So I wanted to add one quick thing. Connor, thank you so much for connecting people via Gitcoin. The best thing about Gitcoin is all the people that we got to meet in the past months. It's really amazing. The talent that is gathered in that platform is just like really, really top quality. So that's really amazing. And stay on the lookout, because we are doing, with every release, we do a different kind of activities. We always do them at Gitcoin. So you can just like pop by or check our blog, whatever works for you. And you will see there's something for you. We're as well, because these are the very early stages of our project. So our idea is to incentivize till our project is on a stable phase, where people don't need the extra push to put up with a little bit of the nascent technology that we're actually building. So yeah, there's always some activity for you, either like from the more elementary activities, such as running a provider node, to the amazing things that you saw today. There's really something that you can do. And aside from that, we also have an awesome Golem. Awesome lists are lists of projects that are built on top of platforms, and they're hosted on GitHub. Matthias here has been building it with the help of Philip and sometimes of Doc. And we are preparing an index of everything that's being built on Golem historically. So you can already use that and check out all of the projects. And one final thing, also big thanks to all of our judges, and special thanks to our first community judge, Ethereum CPW, that helped us a great deal and provided the community perspective.
Yes.
Sure. Thank you, everyone.
Yes, thanks everyone for coming today and seeing the awesome projects. It has been a very fun hackathon, and getting to learn all of you guys. Some new, some currently in the Discord actively, and yeah. Thanks to Connor for providing the platform, also as MP and Kuba mentioned. Much appreciated. So with that, I will round off the show and tell for today. Looks like we're pretty much on time. So I want to wish everyone a good evening wherever or whatever time zone they're now in. So have a good one, everyone.
Awesome.
Thanks, everyone.
Thanks, everyone.
Bye.
Thank you so much.
Thanks, everyone. Enjoyed this.
Thank you.
Thank you. Thanks, everyone.